Welcome to the Tech League podcast. Hello and welcome to the podcast. I'm Toby and I'm here with my regular co-host Krisztian. And we have no guests today, but we will at some point, I'm sure. So this week we're talking about microservices and monoliths.
I think most listeners will be familiar with the concept. I think we're using these terms for 10 years now, but it's still worth discussing. I think because it's most often misunderstood. Just by definition, a monolith is something solid and robust, a colloquial term. But in software terms, it's considered to be considered to be a monolith when it has different parts of the same application tightly intertangled in one big component. So if an application fulfills multiple roles, but it's still implemented as one single deployable component,
like one artifact that gets deployed and run in one server or whatever.
Yeah, exactly. And then it entails functions that probably shouldn't live together by today's standards. Very simple example, like you have an external API that accepts orders from a customer, but the same software is also doing the billing, which is more like a batch process running every month, sending bills to customers, let's say. Or it also serves as a backend for a UI internally or externally, or it has an analytics interface where internal users go in and look at the orders, do sum ups and whatnot. This was very, very common in the industry. This is how we built software for a very long time. And but then it showed its age, this type of design pattern.
But I think it's coming back again, right? We can go into that a bit later, but it's coming back again.
Yeah, it never went away, really. Is monolith a bad thing? No, it isn't. It's just, it has limitations and it has its purpose and time to be used.
It has been a dirty word for a while, though.
Yeah, definitely. It has a negative connotation. But we can go into details when is it good to use and when not. But in contrast to the monolith, microservices, when you have small autonomous software components that are designed for a specific purpose, and then several of these microservices together form the application that you want to build. In the previous example, you have a separate application for serving external API calls to accept orders. There's a separate one for analytics and a separate one for backing the UI and so forth. But it's the same business function that they might solve, but it's on the technical level, it's divided into smaller components. That's very simply put.
But they're deployed separately and they talk to each other. Thinking more from an ops side.
Yeah, exactly.
Yeah,
and that already shows you can already infer the differences between the different options. For the and you can talk. You're an expert on infrastructure, so you can probably explain the difference from infrastructure side. But for me, as a software architect, software developer, there are a lot of benefits to use a monolith, actually.
Yeah.
It's generally the simplicity of only having to deal with one thing instead of many small things. So that means I can have one repo, right? If I can deploy once and it's running, all the internal calls of the application are happening locally. So it's in memory. It's way faster from that perspective. So runtime, it can be actually much faster to call or implement certain business functions. It has its drawback, of course, but with the microservices, you just externalize the same calls into HTTP calls or gRPC or whatever.
I think we've discussed this in the past, but you're in a way pushing the complexity to the ops teams or whatever, the people who have to manage the network and the deployment pipelines and stuff like that. We can talk more about because I popped into my head just now, has Kubernetes killed the microservice because it's made it so complicated?
So I think so the complexity is one of my favorite topics.
Yeah.
What how do you define complexity? Let's say if I have one service that runs 1,000 times, I don't consider that to be a high complexity because it's just it's just the same thing running multiple times. But we certainly exchange some software architecture complexity to infrastructure complexity. That's what we're doing. But this also, if you consider the same software implemented in two different ways, one with a monolith, one with a microservice, the overhead of running the microservice architecture is way higher. But I don't think the industry landed on the microservices because it's inherently better. I think we were forced to do that.
Because of teams and ownership and stuff.
Yeah,
like that.
Exactly. So one of the drawbacks of the monolith is that if it's the same code base, which actually we can talk about like monolithic repos, but when we're talking about software architecture, monolith is harder to maintain as the team size grows, right? If you have 5 teams maintaining the same software, it's going to be merge chaos. Very hard to coordinate, very hard to reason about the internal architecture, keep the standards on par and so forth. So I think this is one of the aspects. I think organization, like we have massive software organizations now working on the same problem. You had that example, right? Like when you worked at a big Swedish bank, modern bank that had an application. Like I don't know how many teams are working, but multiple digit number of teams worked on the same application, right? So that is definitely a problem.
You have a lot of you have to develop a lot of tooling around deploying from a monorepo in a safer way, and again that's pushing the complexity into a different direction.
But when we're talking about classical monoliths, the problem it becomes the testing, the different versioning of there are just too many people trying to work on the same piece, which always leads into conflicts. The other is the technical side. If in the previous example, if you had a monolith with multiple usage patterns, like let's say the orders are constantly coming in to the same system, and then somebody runs an analytics, and that grinds the whole system to a halt because they saturate the database, and then suddenly the incoming orders are suffering because somebody inside the company started running queries on the database. I've seen this happening so many times. It's not even funny.
It's the horizontal versus vertical scaling thing, and monoliths tend to be vertical.
Exactly. Yeah, exactly. So if you want to scale the monolith, it's typically you would add higher, scale up, add more CPUs,
like
more memory.
A certain Erlang machine.
Yes, exactly. The famous or infamous banking software that needed 2 terabytes of memory to run.
That's vertical scaling.
Yeah, exactly. So there are ways to avoid, like to run a monolithic software almost as if it would be or like bigger consisting of bigger microservices. This is one of the patterns how we migrate away from the monoliths, is when we can't change the old monolith directly, but we can deploy it in different contexts. So in the previous example, you take the same piece of software, like same application, and you just deploy one that only does the API calls. It has the code inside to do the analytics and do the billing and everything, but you turn those off and you just dedicate a few instances to do that. And then you dedicate a few other instances just to be the backend of the UI. Obviously the database is still connected, but you can also do, if you have read-only use cases, you can do read replicas. So there's this twilight zone between the two where you try to make the old monolith look like almost like a microservice architecture. This is not sustainable long term, and you still have to do something about it because it's still the same software, and if multiple teams have to work on it, and then if you start diverging on the different deployments,
it's a very short-term stepping stone. But it also makes me think it's like the very literal definition of a distributed monolith, right? I know it's not actually
a
distributed monolith, but it is a distributed monolith because you're disputing lots of monoliths. But
yeah, you can think about it that way. This is typically just a stopgap measure. Or the system is always down. What should you do about it? Mm-hmm. Well, this is what you can do about it. To isolate the different usage patterns from each other, so they can't influence each other that easily. Like this typically eliminates the memory hogging. Like, so if one part of the application eats up all the memory, typically batch processes start, and then you have 1,000 threads reading all the data into memory and massaging the data. It can have a very big memory footprint, while online processing of orders is typically doesn't require that.
It can't make use of things like auto-scaling very well either, because like there's so many different patterns that it makes it so that it can't scale up and down the system very easy.
Yeah, exactly. Yeah, because you would need different scaling for the different aspect.
Exactly.
And that can have a massive cost implication as well. So if you have a monolith that just because you run a weekly process that aggregates the data and sends out some emails, let's say, and that requires you to have 50 CPUs, then you have to have a 50 CPU cluster to be able to do that. And then you've wasted it for a whole week just to do it, just to be able to run it for 1 week. This is very common. So on monolith, like you can typically see some sort of resource underutilization. Either the CPU is underutilized or the memory is underutilized, because you can't fine tune the instances for the specific task, because there is no specific task. There are too many tasks at the same time. And the aggregate might not be what you can configure on the hardware side.
We're still in a bit of a high level here, but like let's talk a bit more about the benefits of a monolith. Deployment efficiency and getting started quickly. You can get really started quickly, and lack of complexity in the infrastructure, as well as like conceptually from a developer point of view, it's easier to read everything locally. And maybe with AI tools, I know we banned AI, but they can scan the whole context a lot easier of the whole system.
Yes, certainly. There's a much simpler system architecture here.
Mm-hmm.
It's one thing running, or in a few instances, you need maybe a load balancer in front and Bob's your uncle.
Yeah.
Right. Like you're solved, like, because you can't efficiently auto scale it really.
You got one firewall, you just open up multiple ports, you have it listen to different ports. It's super easy to deploy a monolith.
You can run these, like typically a monolith is just an executable that you can run on hardware as well.
Mm-hmm.
You don't need orchestration. You don't need anything. So it, if we can say there's a beauty in it, like that's what it is. It's simple, maybe too simple for most modern use cases, but there's a place for it for sure. And since we're moving away from data centers, it's less relevant, I think, in most use cases. Yeah.
But I still see startups going, oh, we just put our stuff on EC2, one machine running this SCP, the jar file over, and then run it. It's very simple. Yeah, you can get going really quickly, and it's very easy to secure because it's so simple. And you don't need a special dude like me to come and build you out a server, like a serverless or a container framework.
Yeah, even my grandmother can run a jar for it.
So in your opinion, what is good about a monolith? I could say what my opinion is. It's easier to deploy. There's a lot less complexity involved with both having the idea of the system in your head as well as like all the infrastructure surrounding deploying it.
Yeah, I agree. I could formulate it as it doesn't come with unnecessary complexity out of the box or day one. Because if you start a microservice architecture, you have to have a coordinator or like some because when we say microservice, we typically mean containerized applications. These are not equivalent terms, but that's the most common way of running microservices, which means you need a container orchestration layer, which means you need an ingress solution, you need loggings. Everything suddenly becomes much more complex on the system architecture side, infrastructure side.
Makes it a lot harder to get started, especially for startups.
Yeah, so if you're not making any money yet, you want to run as lean as humanly possible. So maybe there's a place for monoliths in that scenario. You don't need a DevOps guy or like a infrastructure guy, I would say. You don't need have to run baseline infrastructure that much of a baseline infrastructure, and you can get started quite quickly.
What other benefits are there?
Well, as we mentioned, like it can be faster because you don't have to do external calls between the modules. It's easier to maintain. If you have to upgrade, let's say Java, upgrading the Java version, or if you're using some framework like Spring or whatever, you have to do one update and everything is updated. If you're running microservices, you have to do it n times.
And I was also thinking like distributed security is a lot harder. So it's a lot easier to secure the application. You just use one code scanning tool or whatever.
From a network penetration point of view, yes. But then because you have so many functions together, if you make a mistake in the billing side, or let's say maybe on the UI backend, like the backend for the front end side, if you make a mistake there, suddenly you expose your billing service as well, and the order management system and the analytics system. So
massive blast radius.
Yeah, exactly. So from a security perspective, the blast radius is too high. That's why, in big companies or like sizable problems, companies with sizable problem, like we don't like to use it, of course.
Okay. So the good things are it can get you going really quickly. There's less infrastructure complexity. You don't need as many people, really. There's some specialized knowledge you don't even need as well. I'm thinking like in terms of cloud, you can just spin up an EC2 machine and then put the executable on there and get it going.
Or run it on hardware, your own hardware, which is a benefit. It's running a microservice architecture on bare metal is not trivial. Then you have to add the orchestration later, and then you're already at high complexity again.
And then, in terms of like infrastructure security, you can have you have a lot easier view of like the network, what is public facing and what isn't, what security groups or networking firewalls are implemented and stuff. So it's a lot easier to reason with.
Definitely.
Yeah.
Access control and everything. It's the same for all. If you run 3 instances of the monolith, it's the same. So it's easier to protect, I would say, but the blast radius is much higher if it doesn't go your way.
And then I was thinking it's a lot easier to like maintain permissions for who can edit the code and stuff. Like, because if you mess up, like say you have a big, like 100 repos and you mess up on one and you accidentally give access to someone else, then they have a way in. It's just the whole, complexity is a security risk in itself. And the monolith doesn't have that because it's very simple.
Yeah, and if you want to say about like negative things, like the resiliency of the application is much lower. It's not as resilient because if anything goes wrong with any component, it might have an impact on all of the components.
You can brute force it if you have the money. You just have enough running, if it can support that. But there's some that can't support, multiple instances running of the same application.
Yeah, exactly. So that's a common software architecture error where you design your application with a single instance in mind. Right? So if you do in-memory caches and in-memory counters and these type of things, and some of the monoliths that I have encountered were actually very hard to even run in multiple instances.
Yeah.
Or impossible to run in multiple instances without refactoring.
We can get into a bit more if we go to horror stories, but I've seen monoliths that have the database running on the same server. Like the monolith and because they didn't the latency, they were like it's too slow if they tried to have the database somewhere else, but like, and then it's impossible to scale that unless well, it's not impossible, but it's very difficult.
Yeah.
Okay, let's go on to benefits of a microservice. The opposite of everything we just said.
Yeah, exactly.
I mean, like the benefits. Let me think from an infrastructure perspective. I don't think doesn't feel like there is that many benefits. It introduces lots and lots of complexity into the infrastructure. You have to be clever about how you design the tooling once you start getting into microservices and like a distributed system. because where are the lines of responsibility drawn? So say you have, I use Terraform all the time. Let's use that as an example. So I use Terraform to spin up an AWS environment. Then I have a baseline configuration. So I have things like ECS clusters, networking, security groups for default security groups, deny all the networking stuff, authentication for the organization or the account itself, roles that need to access the account to do account specific stuff. But then you have to start thinking with each service comes additional components. So this one I'm doing at the moment, each service has a ECS task definition, a ECS service, a security group assigned to it, an application load balancer, an ECR repo. There's a bunch of things. So in microservices, you have an application that does a specific thing or role within the company, and it just does that. It has some in and out interfaces, ports, whatever. And then all the infrastructure that needs to be provisioned for that one service lives with the service.
It's easier to couple the infrastructure with the business function, the code. Like I like to, because you were talking about the baseline infrastructure, but to deploy an application, I like to co-locate the application deployment information with the application itself.
That's what I'm saying in a way. It's like anything that has to exist for that service lives with the service in the same repo. But anything that has to live to facilitate multiple services, that goes in the general repo. This is one of the downsides of microservices, is that you have to start thinking about concepts like this. You have to think about where the line of responsibility is drawn and what owns what. And it becomes, in a way, well, it does become more complex. If you think about it for a long enough time, you can find these like lines within the organization or development teams where you can draw these lines, but it requires some forethought.
Yeah, definitely. It's typically organized into one team who does the baseline service offering, and then the teams can focus on deploying their own microservices. I think, and this is where certainly we have to acknowledge that the infrastructure became way more complex. Yeah. And we also demand more from each individual, like developers or each individual team. They have to be cross-functional, or they have to learn a lot more tooling, a lot more concepts. But I don't think it's a bad thing. It used to be coders wrote code and then threw the code over the fence, and then somebody deployed it who knew how networking works, what the load balance is. But that resulted in really poor code quality. Because I had this in my experience. Like a developer didn't know what an IP address is, or how it works, or how DNS works, or anything like that. So how can you develop a software on the internet if you don't even know the basics? So I think we moved away from that. We demand much higher expertise from the developers as well. But I think that improved the code quality. Going back to the similarities actually between the monolith and the microservice architecture, if you can mess up exactly the same way. So you can design a monolith internally in a really nice way. We have techniques for that, like N-tier replication. You have a storage layer, you have the data access layer, you have the business layer, you have the representation layer. And if you're designing your software that way, it's easy to maintain internally. And actually, and also, of course, if the business layer is modular as well, it's easy to transform into a microservice application, microservice architecture. But you can make exactly the same mistakes on the microservice architecture that you made internally in an application, but it's much harder to fix. Because if you made architectural mistakes in a microservice architecture, it involves by definition several teams, several applications. It could be that the whole architecture has to be redesigned, how the routing works, how the load balance, which service calls what, how do we do authentication, and that's a really hard thing to fix. While in a monolith, you can just do a big refactoring PR and you're done.
Because then, if you're having to do migrations in a production system as well, you might introduce outages, you have to do a migration strategy. There's all sorts of extra steps involved in.
Exactly. You have to coordinate between the different. Imagine like the database is split also into, single purpose databases associated with microservices. And now you have to do a refactoring of the data structures or the fundamental data model that you used in the company. If that was wrong, it's a nightmare. It takes years to do such transformation. So it's not all, sunshine. sunshine.
I think it's sunshine and fun if it's done properly.
Yes, we have to, and it's so interesting because what used to be software architecture became like the same principles now have to be translated into systems architecture.
Mm-hmm.
So modularizing your code became the microservice has to fulfill a single function with clearly defined interfaces. So it's exactly the same concepts, but we have to apply it at a different abstraction level, not in a Java class or Java module. Now we have to apply it at the service level.
And then you go, ops guy, can you fix all the wiring, please? And you go, okay, fine. Yeah. Because calling a Java function or whatever, a class, easy peasy. But like calling a service to service requires a whole other discipline.
Yeah, exactly. So we need more experts or like more disciplines involved in these changes. And that's why it can be actually problematic to use microservice architectures if you're not ready for it. If your organization doesn't have the skill set to actually run microservices, you don't have to. Is the message. I'm not an advocate for monoliths.
No.
Half of my life is about is architecting away from the monoliths, but it doesn't mean that a microservice architecture is always a better solution.
No, I think I'm an advocate for the right tool for the job.
Exactly. But because of this negative connotation we have with the monoliths, it's a hard sell today.
Mm-hmm. Yeah, you can't go to any corporate. And the thing is, once you're at corporate level, like, you know what I mean? I'm talking like 200 people plus. There's no point having monoliths anyway, really. It doesn't make sense. But you can't go to even to like any startup these days and go, why don't we just make a monolith? And they'll look at you like you've just, I don't know, shat on the table or something. But...
Yeah. I mean, maybe because we're seeing more and more less, I almost said educated, less trained people in software engineering creating software. Mm-hmm. With the new AI tool, maybe we will see a reemergence of monoliths.
I mean, they started calling distributed monolith, which is, like microservices. But it's a derogatory term for distributed systems. There's a shift, I think. More and more people are employing monoliths, but probably not in the right way either. But then with a lot of these like vibe coding tools and stuff, it's more a JavaScript framework that deploys to Lambdas, but they have no clue what's going on behind the scenes. They sign up to Supabase, they get an API key for their application, or they even in Versal now you can click add integration Supabase, it puts the environment variables straight into the environment, and then you can just call the database and you have a Postgres. And they have a folder that you can put is in your repo, and you can update the tables and everything. It's really seamless. So that's where it's going, I think, more. But this is more that's web apps. It's when it comes to anything backend, you're still going to be using Java or Go or Rust or something like that. That's another point that I was going to bring up on the downsides of and a plus side of microservices. The team can decide what technologies they're using. Is a plus, but it's also a negative. Plus, they're happier, they can probably be more productive, they're more invested in the technology. Negative, you can't cross-pollinate, it's hard, sometimes it's harder to hire, it's harder to have a general oversight of the system health, you have to make different tools for them, so it's a plus and a negative.
Yeah, definitely. And what we're seeing in the industry is smaller companies tend to have higher diversity technology, but as they grow, they just by business needs, they are forced to consolidate. And I'm typically part of these transitions, trying to find a viable path, because everybody likes their own little tools and they want to use a language. like a specific language, and that just creates such a fractured landscape that it becomes very, very difficult to scale efficiently.
We've both been through this. I've had to give like lectures on why it's better to have a standardized way of working. Oh, you want us to build all of these fancy tools for you? Pick a language and we can make it really good. If we have to generalize, it's going to make it way harder and it will take us longer to get there.
Yeah, and as you mentioned, the hiring is because super difficult, because if you have 7 different languages and you hire for those roles, you have 7 pipelines. Seven tiny pipelines typically, or harder pipelines. If you pick one, and then you can concentrate the efforts to hire good talent for that technology. And honestly, I don't care about the language that much. I care that the services can be handed over to other teams, and that we can easily, because originally the idea was that we create so small services that it's easier to rewrite in whatever technology you want when you want to replace it than to take over the maintenance. But the reality is not that. That's I think that was a pipe dream. What reality is, like how we define the microservice, like it fulfills a specific business function. So business functions tend to be big enough that it's not trivial to rewrite. Like if you think about a billing system, like it's not trivial to rewrite a billing system overnight, right? So that premise is false, I think. So we have to consider this. And I totally understand from a developer's point of view that you want to use your favorite tool. Like we're all super opinionated in the industry. We want to use, because our tool is the best, right? Because that's what and frankly, we're the most effective in what we like to use. But in the end, it has to translate to success as well. And in the end, like if you think about the big picture, like does the customer care if you implemented something in Go or Java? They don't even know, don't care.
But something that just popped into my head was it also like really affects the business adaptability, because you can't shift resources, people, I'm talking about this case, into different teams, different areas. If they're all using the same stack, Spring Boot, whatever, they're all using the same deployment tooling, it's super easy to move people around and adapt to different challenges. Yeah, but that's way too high for your average software engineer. They're not thinking like that. They're thinking, I would rather, I go into work at 9 and I want to do Go. I don't want to do Java. Why are people making me do Java? That's a communication thing, because you can make people understand that. It takes a lot of time, though. I've been through those long discussions.
I know developers who want to work with a specific language, and that's how they choose the job. But I see a huge danger in that. If you hire a person who's there for the language, so that's the equivalence of they bought a very nice impact driver, and all they want to do is using the impact driver. They don't care if you're building a house or a boat. They're just going to use it, right? And then how do you align that with the business goals, or how do you align it with the outcomes that you want to have in the team? You can't, because their goal is to use the tool, not to solve a problem. I'd rather like to see people who are looking at a problem and start looking, as you said, like what's the right tool for this job? Not like I have this awesome tool, let's solve all the problems with that. That's not how life works.
It's very, that sounds, and I've seen it as well, it sounds very detrimental, because people can get a bit stubborn with it as well.
Yeah, definitely.
But then something we talked about a little bit, and is another negative of microservices, is you can end up with nano-services, which is just the worst as well. It's like way worse than a monolith, in my opinion. Is where you have services that do too little, too small, and then you end up with thousands of different ones, and the complexity explodes, and all of the infrastructure required to like keep them all running explodes, and you get to the point, it's like diminishing returns. Yeah, that's the one. But that's I do see, I've never seen it myself. I've never seen a nano-services, because I stomped it out before it happened.
Well, if you go too nano, you're just doing function as a service, right? Like AWS Lambda or GCP functions.
We will get into that whole thing, because that's event. Then you have to choose a different type of architecture entirely. You have to do event-driven. That's the only way that works, I think.
But we can. But if you take it to the extreme, like if you think we started in with a monolith, that everything was within one process, if we modularize it nicely, we could take one module out and do network calls instead.
Mm-hmm.
If you break that little piece down further, then you have functions within that module, and that's where we are now with the technology. That's
functions
where,
as a service.
yeah, functions as a service. You exchange like even function to function. Well, it's not equivalent really, because as you said, like it's more suitable for event driven, because it's not recommended to do function to function calls in a function as a service environment.
No.
But it's definitely another step towards a smaller deployable unit, and even caring less about the infrastructure from the programming side. When would you use monolith, and when would you use a microservice from your perspective?
I would use, I don't think I would ever use a monolith.
Ever?
I don't, well, okay, let's back up a bit. Say when would I use a monolith? Say I'm building a simple, not an application that's going to be one or two people working on it. It's a web app that does a certain thing, has a database, has some backend, some email calls and stuff. It's going to be pretty self-contained in itself. If it's at a point where I don't see it scaling past a certain point, or I don't see the project going past a certain point, I won't build it properly from the start. The tricky thing here is that I think I could build a microservice service as quick as a monolith.
Yeah, but you're too skilled in the infrastructure.
Exactly.
So let's say if you have a team who consists of a junior developer or two junior developers, you have a startup, you just want to hash out a new idea.
I would use a monolith until I was at 2 teams, probably. And that's just I just pulled that out of my ass, that number. But like, until I was at a certain amount of people, if I had to, okay, let's think about this another way. If I had to deploy onto EC2 machines for whatever reason, or if I had to deploy onto hardware and I was starting out, then it would be a monolith until I needed to change it. If I was deploying to, if it was a web app, I would go reversal, but that's straight onto Lambdas.
Yeah, so maybe we have reached a point in the industry where we have so many good tooling that there's very little excuse to actually build a monolith.
Yep. But the thing is that we might need to redefine a little how these things are called a monolith, because say you have a Next.js project, and that's yes, you deploy it and Versal nicely deploys it to Lambdas. You don't even see it. That could grow to a point where it's considered a monolith, but it's deployed to Lambdas.
100%.
So all within one code base.
We have seen this before in a simple web application where the web application does its business function, fulfills its business function, but it also has to send email. It's a pure web app, but it has to send emails to the customers. It has to have a scheduler because we have to follow up on business actions. Yep. It has to send like analytics to Facebook. It has to send updated user database with the mailing provider, as you know, like a mass mail sending provider, and it also is integrated with one of these orchestration services like Zapier. It's a small application, but it has so many technologies built into it that which are not directly to the benefit of the visitor of the website, so it slows the system down. Yep. I would consider that a monolith in a sense.
Yep.
Right.
But like, if you think about it from a high enough level, it's function as a service. It's probably events and stuff in the background.
Architecturally, software like implemented as software as a service, but but it's in reality,
it's a monolith. Is that a distributed monolith then?
Yeah, maybe you can call it that.
So, but I would be quite happy with that until the company was making enough money that I could like. Because if I had 2 juniors, maybe a mid-level guy, and very few infrastructure people. If I had a dedicated infrastructure person that I knew was good, I'd probably try and go for serverless earlier. It depends on the team. But monolith is good at the start where you have less infrastructure experience and you want to go fast. because just deploy the one thing, build simple pipelines, get everyone going, get stuff out of their way. When would I use microservices? If I had multiple teams, that's a must, because you want to divide the responsibility. They want to be able to deploy without any issues. If I wanted to scale it, well, if it had a very fluctuating scaling pattern and the different applications scaled in different ways, that's a perfect use case for microservices.
Yeah. Availability is also a factor here, because if you're running monoliths typically on instances, it's very hard to coordinate outages or prevent outages. Even if it's a well-designed monolith that can be deployed in multiple instances.
If I was going to put my SRE hat on, it's a lot harder to get insight into what's happening within the greater application if it's a monolith. You can't, because you can see the CPU and memory going up and down, but you don't know what process or what functions or what part of the application is doing. You can dig into it and find it, but it's a lot easier to see, oh, the billing container, they're scaling on memory, they're taking loads of memory, there's something wrong there. Yeah. You know what I mean? It's a lot easier to isolate.
Yeah, exactly. And the failure modes are easier to handle because you know exactly where the failures are and you know exactly what the impact is. But if your company doesn't have high volume, let's say you don't even make money, then on your because you're in a very early startup phase, maybe it's just wasted time to spend your investment money on infrastructure and that don't really translate into business goals. So that's where I could see maybe that where I would advocate for something as simple as possible, which would probably become a monolith in the end if you don't have money. Because if you're wasting, let's say, a very limited amount of investment in a startup and you're burning that on building the right, what we consider a good architecture, and then you produce no business outcome, what was the point? Right? So it's a failure in a sense. So sometimes we have to hold ourselves back on the tech side and actually recommend what we know is not the best solution. It's an equivalent to you start a delivery business and you buy a super expensive car to deliver the goods, right? Instead of buying the cheapest banked up.
You have 5 packages and you hire 5 people to send them because it's the quickest. Instead of hiring one person to drive to each. That's what I would say.
Yeah, exactly.
I'm thinking about one of the ones I'm working on at the moment, because they want it done right from the start. So I've been doing ECS with Fargate because we're too small for Kubernetes. But the developers in that team, they started by writing microservices. So each part of the application is written in its own thing. So then it makes sense to build a container. But then I decided ECS with Fargate is way simpler. It's super easy.
Nobody should ever run Kubernetes, in my opinion.
No, I agree.
Maybe it's an extreme opinion, but I think that is a symptom of the industry jumping too fast on the microservice bandwagon when we didn't really have mature technology enough. So we had microservice-like architectures before. We used to call, like 15, 20 years ago, we used to call it service-oriented architecture. That was the alternative of the monolith back then. But it's very, very similar to the microservices, but there are differences. The software-oriented architecture was based around the concept of a message bus, and every message went on the message bus, and there were like transformers who changed one format to another, and everybody could listen to messages. Very, very similar to a microservice architecture with event-driven microservice architecture, but it was a bit more rigid, I would say. But then we started containerizing.
Containers was the big explosion in microservices.
Yes, and then every company started running Kubernetes clusters. We've done it. We had some technologies before, but Kubernetes
we were very far ahead of the industry trend. We embraced microservices and containers, but for most people. Yes, so we were doing Mesos Marathon before Kubernetes was even a thing. It was Borg, and they were talking about Borg, and that's what ended up being Kubernetes.
Yeah, but in the end, what I'm trying to get at is we got to everybody wanted to use containers, but where do you run containers? And the cloud providers weren't mature enough yet to run it for you. So everybody started deploying Kubernetes themselves. And then they just shifted the problem from the bigger systems architecture into Kubernetes. Okay, but how do the services talk to each other? How do I do service-to-service authentication? How do I do ingress? How do I do security? How do I do logging? How do I do metrics? And that we created an microcosmos within Kubernetes that we still had to run in a bigger infrastructure. And I think that was a sort of a mistake in a sense.
You're preaching to the choir here. You know I hate Kubernetes. Not because of what it is, but because it's too complicated. Or people have a tendency of overcomplicating the setups.
Yeah. We've seen projects where companies try to run Kubernetes on their own. They burn millions of euros with zero outcome. So I think the cloud services are way more mature now. So if you're not using those, you're probably making a mistake.
Yeah, I mean, ECS is good.
Managed Kubernetes, ECS.
But there needs to be something like Cloud Run in AWS, because Cloud Run is the peak, I think.
What is it called?
App Runner is not as good. It's not as good. With Cloud Run, you just say, I want this container running with these ports, and it'll give you a URL. App Runner takes a while to set up.
Yeah,
it's not that easy.
So me as an architect or let's say business owner, I don't even know what a Kubernetes thing is.
You've heard the word, but that's it.
No, I'm unfortunately too familiar with it. But we shouldn't need to use this concept in a regular business-oriented company. If you're a tech company who's focusing on infrastructure, yes, of course you should be an expert in that. But we ended up in a situation where every company has to run their own Kubernetes clusters one way or another and add on like 15 different technologies on top of for mesh communication and ultimate deployments and Helm charts and all those complexities I think are unnecessary to actually fulfill the business function. So I think this is a curse of the microservice architecture in a sense, because we forced the industry to go into this way. And I'm hoping for a consolidation where we go more towards a low effort of deploying a container. So I think that needs some standardization and other aspects. But even today, if you're running your own Kubernetes cluster, I think you're wrong.
There are some use cases, like I could see how, say, a hospital should run one, maybe. But I don't even see why. I mean, if you can't host your stuff on the cloud, there's got to be some use cases.
Okay, you need local. So if you're running, you own the hardware. I agree.
So I've seen it with like AI model training on-prem and stuff, but there's the same. But I would still say you don't need Kubernetes. You never need Kubernetes. The only good thing about Kubernetes is the unified deployment way of interacting with the clusters, the CLI, kubectl, whatever. But I bet you I would go, if I went into any company and I looked at their Kubernetes cluster, I'd say you could probably throw out half of what they've implemented. You don't need a service mesh. If you get to a point where you have a service mesh, you're doing something wrong. It's usually MTLS they're complaining about. Oh, we need some way of securing applications. Use SSL. Use HTTPS, right? That's a super simple way of fixing it.
Another mistake I usually see in this sphere is where everything is built around Kubernetes, therefore you cannot run any workload outside of it that interacts well with those services. But to me, the feeling I get is that Kubernetes is a great technology. I'm not bashing the technology itself. It's just, it's in the wrong hands. This should be used by service or infrastructure or compute providers, not by every single company on the market.
I'll tell you what it's really good for. It's a good data center OS. I think that's what they initially envisioned it as. Like, you have 20 racks of servers. They're all in the one Kubernetes cluster, and it can self-heal itself, merge stuff around, and then you provide some way of people accessing certain workloads or whatever. Like, it's supposed to be big and distributed, but it's become what people want to deploy to. I think it's because it's got Google behind it, so they managed to push it super hard. The issue that I always run into, and it will go back to complexity again, I've seen something as simple as Terraform, which is probably one of the simplest tools possible. I love it because of its simplicity. I've seen that being made complicated for no reason. I'm not sure if it's a sign of a bad engineer or if it's just like people like to, I don't know, show off or whatever, but like there's this tendency to overcomplicate things, and nothing shows that more than Kubernetes, I think.
Mm-hmm. I've never seen two Kubernetes clusters that look the same.
No.
So that tells like it's but we're solving exactly the same problem. You want to run containers, they need ingress, like they need an HTTP endpoint, they want to talk to each other, they want to talk to a database maybe, and you have to have logging and all the other like non-functional part.
We're going back to the talking about how microservices push the complexity more to the infrastructure, and Kubernetes is meant to address that, but it just becomes complexity as well. And then you have to hire really expensive people to manage Kubernetes clusters for no reason.
And if you add the overall complexity together, the underlying operating systems, or like the Kubernetes, the applications themselves, the microservices, the orchestration that needs to happen, the auto-scaling, the ingress controlling, the controllers and security, and the increased security requirements or exposure. If you compare it back with the monolith, you can ask the question, is it worth it? So I think the only very, very strong reason to go for the microservices is resiliency and better performance for the customers, higher availability. And because if you would take that away, or if you could solve it with simpler deployments, and I'm talking about the technical side, of course, there's the organization side is still valid. I wouldn't say it's worth it.
It's
but
not.
We're forced to do it. So it's the higher demand from the market actually forces us to do this. You remember, like banks used to be down for maintenance, right? Like they were just, okay, you can't do anything now. It's unacceptable today. So we're forced to manifest this complexity somewhere, and it happened to become the infrastructure where we became complex.
I would be okay with Kubernetes if you couldn't put plugins and stuff in it. No, I'm trying to think, like, if there was a really opinionated Kubernetes cluster that you could spin it up, you're allowed, because I like the service and the pods, and I like all of those concepts, right? That's good. Multiple containers sharing the same network namespace, good idea. Having some sort of internal load balancing and service discovery, good idea. And then having some way of automatically provisioning load balancers, good idea, all right? And then maybe you have a controller that pulls in secrets and puts them as environment variables. Maybe some sort of storage. What else do you need? You don't need anything else, really. I mean, there might be need for, I don't know, firewalling in the cluster, but if you just shouldn't need to firewall in the cluster. But like, if you just had that subset little thing, deploy that, allow people to access their own namespaces or whatever. That's all you need. Really, that is all you need. You don't need it. Like, if anyone says you need anything else, they're talking rubbish, in my opinion.
So you mean you could keep such like microservice, and now we somehow went into the Kubernetes discussion, because you can run microservice architecture without Kubernetes as well.
Yeah.
But it's the most common for sure.
Something I push is you should have a container orchestration framework.
Yeah. But you think we could keep the complexity much lower than what we tend to do today?
Yeah, I think it's all our own fault, the complexity.
My argument is companies shouldn't even need to care about this. There should be deployment descriptors that just magically deploy in the infrastructure because somebody else runs the Kubernetes cluster. Why do I even need to know the existence?
So what we need is another standard, another thing.
Let's solve
let's think about the business problem here, or like from a developer point of view. I want to deploy my service, and it has certain inputs and outputs, and it needs to pull certain things and talk to certain database. That's usually the use case, right? There's not much else.
Yeah, exactly. So if a company is starting to talk about Kubernetes clusters, there's something wrong.
Mm-hmm.
Because this is the equivalence of, I'm a delivery company. I'm going to start building cars.
Yep.
It's a wrong abstraction level, because what the delivery company should think about is delivery routes, and fuel efficiency and these type of things, not basic infrastructure. And now almost every single company is building basic infrastructure again and again, and we see the same pattern repeating. So every company implements their own Kubernetes clusters with a little bit of differences, but overall they solve the same problem. If you can buy that on the market, for God's sake, buy it on the market. Don't try to build it yourself.
It's exactly the same as the old DC versus cloud argument.
Exactly. So I think that's where we messed up a little bit with the microservices. We could be way more efficient, but it's not the microservice architecture's fault. It's just it caused this problem. So maybe it's not worth discussing it this much in this topic. But that's what I don't like about this architecture. So maybe it was premature when we started using it. The providers were not ready yet.
Yeah, they weren't, because Docker was like an explosion. Everyone thought it was the most amazing thing. And from a developer perspective and for a ops team perspective, it's really good because you have an artifact that runs repeatably, can be built in the same way, and you know what you need to deploy. It's no more like faffing with what was it called, Tomcat and crap like that to get the settings working right so that the Java file works properly. They give you an image, you run the image. It's a really nice dividing line of responsibilities and repeatable artifact. So, but it exploded onto the scene, and then there was a lot of different things. There was Docker Compose, and there was Mesos, and there was a few others I can't remember. We used Mesos really well, I think, really nicely, but it missed a few crucial features, like we had to make our own load balancer controllers and stuff for it, or like we had to make a service that would template a load balancer to point to workloads within the clusters, and our own deployment tooling. We had to abstract stuff away and use it was Ansible or something. I can't remember what we used, but we used something that then called the API in Mesos and deployed the stuff. But it was conceptually very simple. Just run this container, this amount of this container. What Kubernetes added was the idea of pods with the shared network namespace, services, ingresses, and some controllers. And like I said before, I had Google behind it, so everyone went Kubernetes then. It killed off everything else. I think we need another one to come along. I don't know who's going to do that. I don't trust Amazon to make it because they can't make it properly. Google made, like I said, with Cloud Run, really good. That's the kind of abstraction that I think we need.
Yeah.
Post to an endpoint, run this container in these regions, this amount, this is the scaling strategy, these are the secrets I want to pull, these are the ports. Just do it.
This is memory requirements, and so you could translate it into very simple terms.
It should just be one API call, because I don't want, I like ECS on Fargate. It's serverless. I don't have to worry about scaling or anything like that, but I still have to set up an ECS cluster. I have to go through all of the Terraform to set up everything around it. I have to set up ALBs for services and stuff. I shouldn't need to do any of that. It should all be there, ready to go. And I just want to run this container. That would be the right way to do it.
Exactly. Yeah, I think so. So that would be to the benefit of the businesses, actually.
Okay, so let's just try and think of how we would summarize these two things. What are our conclusions around our little rant today? Go.
Thank you. I would say, obviously, the microservice architecture is the standard today. Almost every
it's the de facto.
It is the de facto standard. Without having a standard, we use a lot of principles that are well understood at this point: separation of concern, domain boundaries, breaking down the problem from a business perspective, not on the technology. But these were decades old software engineering principles already. We're just applying it in a new context. So that's going to stay away. I hope we're going to reach lower complexity on the infrastructure side to counteract what we have today. And definitely we're going to go that way. On the, to answer the question, should we ever use monoliths? Yes, probably. If you're a very early startup, lack resources, it's not high value at stake, you're not handling millions of euros per day, you can go with it to survive until you can expand your business. So I would say that's what I would say.
If you're not running into scaling issues, you don't have specialist knowledge on your team that or want to hire specialist knowledge that could build out the required infrastructure underneath. If you don't have lots of teams, everyone talks together and they're fine working together. It's fine to use a monolith, I think. It's even better. Yeah, it's even better. Like, because you want to prioritize features over faffing around infrastructure, right?
Yeah, and when all these things become important, availability and speed of execution, and you have grown the team, maybe that's when you should introduce the complexity. Up until that point, it's just unnecessary complexity.
You have to balance the cost of the complexity versus the potential benefits.
Yeah.
And that it's hard to understand when to do that if you haven't been through it before. So call us. No.
I think for a single team or single developer, like that's the most natural way to start.
I mean, no, it's not, because I think most people are trained to not do that because it's such a dirty word. It's actually, people consider it an anti-pattern or whatever.
Okay, let's rephrase that and be bold and create a monolith if you don't have enough resources.
Yep. Do whatever it takes to go fast at the start and succeed. Think about the business, not the ideas you have in your head about what is the right way to do something. Think about it from a business perspective. What am I doing, and is it going to pay off in the short term when I need it to? Versus, am I doing it right for 10 years down the line when you might not even have a company because you didn't deliver features fast enough? That's how I would think about it.
And if you do a monolith, still do it right internally.
Yeah.
Right, because then it will make the transition much easier.
So how would you're talking about separating everything into the correct, like...
Yeah, so internal, like modularization, have the separate layers of the anti-replication, what I mentioned, that the data storage, data access, the business layer, presentation layer. If you keep those principles, software engineering principles in mind when you design the monolith, it's fine. You can easily break out the modules because they will have clear interfaces, and you just trade the local in-process call to a remote call. That's what it is.
And design the monolith so that you can have more than one running at the same time.
Yeah, that's a common mistake. If you're assuming while writing the code that it will be a single instance, that's a mistake.
It's going to shoot you in the foot.
There are techniques and for writing good monoliths as well. There's this concept of cell. Cell-based, it's not called monolith, but cell-based architectures where you have individual cells. You can think of it as like sharding the problem. Like you have different shards of the same, and so certain requests go to one shard always, or one cell, and the cell in itself is like each cell fulfills exactly the same business functions, but the traffic is split between them, so you can scale them. If you look up a cell-based architecture,
it sounds like a microservice within a monolith.
No, it's the same monolith running several times.
Oh yeah, okay, yeah, that you talked about the migration step, or
no, this is I consider the running it multiple times because it has multiple facets. It has an API, it has a UI, it has a analytics interface or whatnot, and I was suggesting to separate the deployments based on those facets. But this technology or this concept, the cell concept, is just splitting the traffic, let's say, into multiple instances, and it consistently goes to the same instance.
Okay, yeah.
So they are interchangeable cells, but this is a way to grow it. But this is another whole other topic, so we don't have to go into that. But there are ways to make it, less bad. Let's put it. We're trying to mitigate some of the drawbacks of a monolithic architecture.
So do what is the right tool for the right job.
As always.
So thanks everyone for listening to this talk on microservices and monoliths. I hope it was somewhat instructional. You got anything to say, Krisztian?
No, go with peace.
Okay, peace out. Okay, bye. Done. Nice. Thank you for listening to the Tech League podcast.